Welcome to a journey through the very fabric of our universe. Today, we start our series, Thermodynamics, the rules of heat, work, and reality. Have you ever wondered why a small cup of boiling coffee feels hotter than a swimming pool, even though the pool contains vastly more energy? It comes down to a fundamental distinction that even seasoned students sometimes miss: the difference between temperature and heat. Temperature is a measure of the average kinetic energy of the particles in a system. It is a state function. It tells us about the system's current condition. When we measure temperature, we are essentially looking at how fast those molecules are jiggling around on average. Heat, on the other hand, is energy in transit. It is not something a system has, but rather the energy transferred due to a temperature difference. Think of it like this. Temperature is like the height of the water in a tank, while heat is the water flowing through the pipes. Temperature is an intensive property. It does not depend on the amount of matter. Heat is related to internal energy, which is extensive. We quantify heat using this famous relationship, Q equals M times C times delta T, where M is mass and C is the specific heat capacity. Specific heat capacity tells us how much energy is needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. When two objects of different temperatures touch, heat flows until they reach thermal equilibrium, a state where their temperatures are equal. This brings us to the zeroth law of thermodynamics, which defines temperature as a fundamental property that allows us to build thermometers. It is also vital to distinguish both from internal energy. Internal energy is the total energy stored within the system's microscopic structure. In your fridge, we aren't adding cold, we are removing heat to lower the temperature. We are moving energy against its natural flow. In physics, we use the Kelvin scale. Absolute 0 Kelvin is where all classical molecular motion effectively stops. Understanding this distinction is critical for everything from designing efficient engines to keeping your computer's CPU from melting down. Temperature is actually statistical. It represents the most probable energy state for the molecules in a large ensemble. To recap, temperature is the state of the system's energy, while heat is the process of moving that energy. One is the how hot, the other is the how much. So, the pool has more heat energy to give, even if the coffee cup has a higher temperature. Mass matters. In our next video, we will dive deeper into energy and work. How do we turn that heat into something useful? Subscribe to join us for this series. Let's master the rules of reality together. I'm excited to have you here. See you in the next lesson.